Well, hello, and welcome back. I'm AJ O'Neill, and I will be your instructor for tonight's Beyond Code Live. So, for those of you that are tuning in live, I've got the comments both on Twitch and YouTube up, so feel free to leave a comment if you are watching live. And for those of you that are not watching live, there may be an edited video in the description in the playlist. With that out of the way, what we're going to cover tonight is going to be the difference between primitive types, or I shouldn't put that in air quotes because that's the name that everybody uses for them. We're going to talk about primitive types. We're going to talk about what's called new types, and I am putting that in air quotes for some reason because it's just a word that deserves it. Also type aliases. Now these are features that are typically only available in strictly typed languages. So I'm going to use Go as an example of that to kind of show you how this works. So if at any point you have that aha moment where this clicks for you and expands your understanding, makes you feel like you learned something, please go ahead and give it a like. And also, I'd like to invite you to open up gist.github.com to go ahead and take some notes and let that be something that you can put in your blog that you have in your portfolio. Okay. So let me go ahead. I'm just going to open up a new file here. You can see the vestigial remnants of the temporary file I opened up previously. I'm going to open up a new file. We're going to call it main.go. I've got Go installed. We're not actually going to compile Go code, but if you did want to install Go, I'd recommend using webinstall.dev/go for that. You can look up instructions on there. And also the vim package is vimgo on webinstall.dev. So this is, we're not going to worry too much about what's going on here. I'm just going to leave this default here, and I'm going to type out some Go. So you know probably about some basic types, and so I won't spend too much time reviewing that. But we have something like an integer. So I could do, say, in and assign in 1, and 1 is going to be treated as an integer. And I could have something like f, and I could assign f 1.0, and this is going to be treated like a float. So Go is an inferred type languages, and you can stack these. You'll hear lots of terms, inferred typing, static typing, strict typing, dynamic typing. Some of them are opposites, but many of them can be combined. So Go is a language that is statically typed, it is strictly typed, and it is inferred typed, which inferred is kind of the statically typed version of dynamic typing. So I don't have to explicitly tell this is an int. It just knows that it's an int because it can tell that 1 is an integer and 1.0 and is not. And Rust is this way too. Most of the modern languages have inferred typing where they can just kind of see how you're using it and they know what it is. But that's not what I want to talk about. I'm going down the rabbit hole there. So let's say we have a var I int, we have a var f float, we have a var b bool, a var, what are some of the other types here? We could have an s for string, maybe we could do t for bool since it's true false t, var b for byte. These are kind of our primitive types. And then we typically have some what we could call collection types. Now, Go doesn't have tuples, but many languages do have what's called a tuple, and that is basically just, it's kind of like an array for those of you that don't know what tuples are. It's a list. And then you have some sort of list or array type of thing. Go has these. So I could declare, for example, var, let's say, what do I want to call this? Let's say names is an array of strings. And then we could have a struct is another common type. So we could say type, let's just call this example struct. And I'm not going to go into that, what that is. So I'm actually just going to delete that. So we're not going to talk about the collection types really. Although this feature works with collection types as well. All right, so we got our primitives. And then what we want to talk about first is new types. A new type is when you take, typically, or not, I shouldn't say typically, but often it's a primitive, but it could be another type that you created. But you just create a new type of that type. So let's say that I have an integer. Well, what can I do with an integer? Let's say that I have miles that I'm going to travel. I'm going to travel 100 miles. And if I'm doing calculations in miles, it's pretty important that I stick with the mile measurement. I wouldn't want to accidentally add miles and kilometers together. So if one leg of a trip was 50 mile or 100 miles and another leg of a trip was 50 kilometers, if I were to add those two together, miles plus kilos, let me maybe call that kms, so we don't get confused with weight. But this would not be meaningful. And there are situations where it's late and we're not thinking clearly and we do something like this, and then all of a sudden a $2 billion robot crashes into the surface of Mars. This happened, right? So new types allow us to say type, and then we'll go with miles int and type kilometers int. And I'm just going to, miles are miles. I just want to get the type system, or this autocorrect thing that's telling me, hey, you didn't put a comment specifying what this is. I'm just going to make that go away real quick so we don't have to worry. There we go. Now, if I were to say that I would have to change the way I'm doing this. I could do var miles equals 100, and var kms kilometers equals 50. Now it will not be possible for me to add these two together. So I'm going to go ahead and just print this out, call this distance. And I'm actually kind of surprised that it's not catching it here. I hope I'm not mistaken on this. Maybe it does allow you to do addition on them together. Let's do get distance. I'm going to create a function here just in case that actually does work. So I can create a function that's get distance, and I could say that it only takes miles. So we're going to say d in miles, and it's just going to return back d. This doesn't make any sense practically speaking, but oh, you know what we could do? Whoops, didn't want to do that. We could say we're going to take any amount of miles and we're going to add them together. So that would work. We could do var total miles equals 0. And then we could do for I range. This is just a for loop. Let's call this miles. Or really this would be distances, but I don't want to type that out because I'm lazy. So I'm just going to call it Ds. There we go. Let's do this a little bit. Okay. So what I could do is, I could actually, let's just do it this way. I could do total is plus equal, and then I could return the total. There we go. So I could add a distance together. So right here, what I'm saying is I don't want to take any integer. I only want to take integers that are of the new type miles. And I want to add all of these integers together. So if I wanted to get the distance, and I ran this function where I tried to put in miles and kilometers, it wouldn't work. I would get an error. I don't know why the error handling isn't working. Gosh. Demo fail. Okay. But the point here is I'm going to run this program and we should get 2 errors back to back if I'm lucky and I'm correct. So first is, yeah, here we go. Invalid operation. We could have just left it at that. I might cut this out in the edit. Okay. Invalid operation. Miles plus kilometers, mismatched type miles and kilometers. So you cannot add, even though these are both integers, you can't add them together. It treats them as separate types. And then same thing here in the function. It won't, and if we just put a random number here, it won't work either. So if we just put, say, well, I hope it doesn't work. Let's try that again. Yeah. There we go. So this just kind of protects us. So this, if you have multiple things that are similar but represent something different, because a number can be anything. A number is meaningless without a unit. We could be talking about miles, we could be talking about kilometers, we could be talking about dollars, we could be talking about yen. And so if you have something in your application where you want to distinguish between two things that are of an identical quantifier, 2 is identical, but what 2 means is context specific. It could mean 2 miles, could mean, all right, we're beating a dead horse here. So that's what a new type is. Now a type alias it looks very similar, but it's a little bit different. So what I'm going to do to demonstrate type alias, excuse me, I'm going to run this one more time actually, so that we see that error. Yep. And then we should be able to get rid of that error if we just put this together like that. Now we have no kilometers. Oops. Oh, it's probably float 64. Is it 64? There it is, float 64. Okay, cool. So now it's adding in distance. It'll only add miles. So a new type is a little bit different. New type, or not, sorry, a type alias is a little bit different. So let's say that we have money. And we have time. So we're doing some sort of calculation. And we want to be able to multiply, let's say, profit is equal to, we're going to have var rate and is a money. And let's say that that's $150 an hour. And we'll say that our hours is time, and we'll say that we worked 6 hours on a project. So if we want to see what our profit is, we want to be able to multiply rate times hours, and then let's print that out, profit. Now this, we're going to have the same error as before. I'm going to run it again. We're going to see this again. We're going to have the same error as before, where we say, hey, you can't mix type money and time. Little do they know that time is money. So one way that we could solve this is we could recast things as an int. So we could say, okay, well, when we want to multiply these, then cast the rate as an int, and then cast the hours as an int, and then we can use these types together. We can say go back to an int when your profit, and then we could retype profit to, we could do something like this: var profit money equals. I think this might work. Will that work? I think maybe it will. Let's see if it does. Okay, so yeah, what we'd have to do then, I did this a little bit wrong. We'd have to cast this all as money. Okay, there we go. So now we're going to convert it from hours to integer, no, from money to integer, and from hours to integer, multiply it as an integer, and then we're going to convert that into a money type, and that's going to be our profit. So this will work. But this is kind of obnoxious, right? Like I wouldn't want to do this all the time. And the question is the application such that when I pass something into a function, I'm likely to accidentally pass the wrong thing? I would say I am likely to accidentally pass kilometers when I meant to pass miles, or vice versa. I'm not likely to pass, say, bananas when I meant miles, or I'm not likely to pass in time when I meant money. So that's not a mistake I'm likely to make. So sometimes it's nice to be able to document this, but we don't actually want strict type enforcement. And so in that case, what we can do is we can use what's known as a type alias. So a type alias doesn't actually have a type. It is only something that you see, that you read, but it doesn't actually exist in the program. So before, when we had a new type like this, we're actually creating a new type of number that is the money type of number that is based on an integer. So in terms of how the computer holds them in memory, they're held in memory the same, but in terms of where the program is allowed to use them, they're completely different. When we do a type alias, what we do is say, I just want to be able to document that my rate is in money and my hours are in time, and maybe it would actually make more sense to say dollars there. I won't go and fix that now. But we want to be able to do operations on them without having to cast them back to an original type or to the new type. We just want to be able to work with them normally. And that's what a type alias lets us do, is it says, when the compiler runs this program, what it will do is it'll go through and it'll say, okay, here's an alias. So everywhere I see money, I'm just going to do a find and replace, and I'm going to put int instead. And so it goes through and it just does that basically. And then it comes up to the next one. It says everywhere I see time, I'm just going to replace it with int. Did I say that right before? Replacing money with int, replacing time with int. So this is the same. So now I don't have to do any of the typing stuff. And, oops. I can run my program and it's going to run without complaining at me. So hopefully that helps you understand the difference between the built-in types. We could also call primitives. I spelled that wrong. Primitives, built-in. And a new type, like miles here, or kilometers, and money. So a couple of use cases. I found it really useful in the project I was working on last night, which, by the way, if you wanted to see me work for 4 hours straight, that video is up. I was actually working on a real client project, and there was a bit of code where I had a number of integers they had different significances. And so I was creating type aliases because I just wanted to be able, when I looked at the code and read the code, I wanted to be able to clearly see, okay, this is the database column number, and this is the CSV field number, and these two numbers are significant in what they mean, but they don't necessarily need to be different types. I just wanted the code to read well. There's one disadvantage to using a new type, well, an additional disadvantage to using a new type that we didn't talk about, which is that often new types will not serialize well, or might require special serialization. So for example, if I'm using a common format like JSON, and I have a number in my JSON, when the Go parser looks at the number, it can tell if it's an integer or a float. If it has a decimal point in it, it can assume that it's likely to be a float, and actually you can specify what it is. But when you are parsing new types in something like JSON or YAML or TOML, occasionally you get a problem where it doesn't serialize or deserialize in the way that it doesn't do it properly, or doesn't work with arbitrary serializer, deserializer functions. And so sometimes if you're dealing with data that's going into a database or a serialization format, it's best just to use your built-in primitive types because the tools know how to handle those types and convert them back and forth. Whereas when you're using new types, you might have to just write more code and write more code and write more code and write more code. So you can figure out through experience what's right. I would say that the litmus test is it more clear to the reader? Is it less likely to cause mistakes? And is it worth any of the boilerplate that you have to put around it to deal with conversions and that sort of thing? All right. Well, with that, that's all I had for tonight. I hope that you have a really good one. And remember, if this was something that helped you out, that kind of helped you grasp that concept, go ahead and give this a thumbs up. And you can also subscribe if you would like. There are 2 channels for this. There is the live stream channel, which is my cool Age 86 channel, and then there is the Beyond Code Bootcamp channel, both of which are linked in the description. I would love to hear if you have any questions or comments about this topic. And also feel free to hit me up on Twitter. It is at Beyond Code. At _ Beyond Code on Twitter. If you'd like to ask a question, I will typically find a way to incorporate that into one of the streams and then tweet at you and let you know that I did. All right. So with that, thanks for watching and have a good night. Adios.